Hi everyone, in this video we are going to talk about how we can solve the product time graph questions. This is one step above that of the reactant time graph questions. So let's get started. So assuming we have this reaction, right, A gives me B. So what happens over here is that I will start off with a value, let's say 0.1 for A, and at the start there will be 0B. Alright, so when t is equal to 0, this is what I have. And what happens at the end of the day is at time is equal to infinity, or when the reaction has ended, this should be 0 and this should be 0.1. So this is assuming that this reaction is 100% complete. Right, so what happens is that this is my concentration of B against time, and I'm going to plot a graph that looks like this. So typically, if you notice first order graph, right, you will notice that it will start to curve up and you will reach a plateau, right, where the plateau will eventually be your 0.1, which is a 100%. Sorry, if we were to look at this experiment as a first order reaction, right, we can actually use our half-life to look at this. So at time is equal to 0, I'll have 0.1 of A and 0 of B. At the first t half, right, I will have 0.05, and over here I'll have 0.05. So if I were to change these values all together, I will get x, 0, half x, and half x here. After the second half-life, what we will have is x over 4 here, but the extra 1 over 4, x over 4 actually went to the product side, so this becomes 3x over 4. Right, and so on. Third half-life, it will become x over 8, this will be 7x over 8, and so on. Right. So at infinity, it will be 0 and x over here. So what you'll realize is that after one half-life, I would have formed 50% of my products. After the second half-life, I will have formed 75% of my products. So all you need to do is to look for where 50% is. So let's say, for example, this is 0.5, and we draw a line here. Alright, this is our first t half. And then after that, I have to find where 75% is. So 75% is probably here. So 0.75. Then this distance should also give me the same t half for it to be a first order reaction. So do take note that for product time graphs, you just need to know what is the final value. And remember the two magic numbers, 50% and 75%. And you should be able to find the order of reaction with respect to the first reactant. Okay, so you do have to combine all your concepts of pseudo-order reactions and things over here. Alright, so do take note that even if I've changed this value to this coefficient to 2, this will end up as 2x, this will end up as 14x over 8, 6x over 4, and x over here, you will still realize that this is 50%, this is 75%. So it is the same idea. Look at the percentages. So the next thing that I want to talk about, right, is if I have a few reagents present. So for example, if I have A plus 2B, and that gives me C. Alright, and we know that B is added in huge excess. So what happens is that if we were to go back to our graph here, you'll realize that there is another graph that probably looks like this. Alright, so the ending point might be the same depending on how much A you have added. So if you have added the same concentration of A in both experiments, right, the final amount of C form will still be the same because this is the limiting and this is the in huge excess. Alright, so how do you compare the order of reaction with respect to B over here? So we have to write down a rate equation. So rate is equals to K, A to the power of small a, B to the power of small b. So we know that the order of reaction with respect to A is 1, simply by looking at the shape of the graph earlier. If we were to compare between these two graphs, we can take the initial rate, alright, which is the gradient at the start, when t is equal to 0, and just simply plug it into this equation, and you will be able to find the order of reaction with respect to B, alright, quite simply. Well, why is it that we can use the rate of change of your product to measure the rate of change of your reactant? So what we need to realize is that the rate of reaction is always a positive value, right? And what is it equals to? Is equals to negative of dA over dt, which is the rate of consumption of A. Right, so because you're using up A, the value is negative, so we put a negative sign here to negate it. Right, it's also equals to dC over dt, because the product is formed, is already a positive number, and this is equals to negative dB over dt, right, divided by 2, or times 1 over 2, simply because the coefficient here is 2. So the gradient given for the rate of formation of products is equals to the negative of that, of your rate of consumption of A. So that's why you can simply substitute the rate, right, which is the initial rate at time is equal to 0, to find the order of reaction with respect to B. So this is the specific method for you to apply your pseudo-order reactions, to apply your magic numbers of 50%, 75% to answer product time graph questions.